This video is a high-level introduction to Microsoft's Cognitive Toolkit, formerly known as CNTK. It is a state-of-the-art production-ready toolkit for deep learning. Microsoft Cognitive Toolkit (CNTK) is designed around ease of use, focusing on the problem a user needs to solve and not having to worry about how. Advanced users can certainly deep dive into the toolkit if they want to. The toolkit is designed to be hugely performant on large production scale data. The toolkit is designed to be extensible, and the latest V2 Python API release lends even greater flexibility. One can provide one's own Python functions and additional interoperability with NumPy arrays. CNTK embraces fully open development framework, that is, there is no separate code branch internal to Microsoft. The toolkit is tested in production setting for accuracy, efficiency, and scalability in a multi-GPU, multi-server environment. The toolkit is also designed to bring Lego-like interoperability and extensibility, allowing for expression of arbitrary neural networks by composing simple building blocks into complex computational networks. Several use cases have been built using the toolkit for speech, image, text, and combination of the data types. The toolkit has been used widely within Microsoft. Microsoft Cognitive Services uses CNTK for several tasks in speech, vision, and text-based deep learning applications. Microsoft Customer Service Bot, Face Detection Framework, to name a few. Machine translation problems are very amenable to solutions based on deep learning. Skype Translator efficiently uses such technologies. Cortana learns acoustic models using CNTK, which provides scalable training on very large datasets. Bing uses the toolkit for relevance and ranking. Bing Ads uses the toolkit for recognition of products in advertiser-provided images, in addition to other predictions and relevance problems. CNTK is used for object recognition in augmented reality applications. Within Microsoft Research, CNTK has been pioneered and continues to extend the deep learning technology frontier. The Imagenet project is a large visual database designed for use in visual object recognition. Since 2010, the Imagenet project runs an annual software contest called the Imagenet Large Scale Visual Recognition Challenge, ILSVRC in short. Software programs provided by the different teams compete to correctly classify objects within images, that is, say whether a dog or a bicycle is present in the image. Another aspect of the challenge involves detection of objects, that is, identify regions where a dog or a bicycle is located in the image. In year 2012, the introduction of deep learning reduced the error on ILSVRC task by approximately 10%, going from 25 down to 16, powered by pioneering work done by Hinton and his colleagues in Toronto using AlexNet with 12 layers. In 2015, the winning algorithm called ResNet from Microsoft came up within error margin of only 3.6%. This network with 152 layers is 8 times deeper than BGG, which was the winner in year 2014. So by training on larger corpuses and deeper networks, one can get to a higher accuracy provided you have a large set of data. And CNTK embodies these advanced algorithms that is available to user in an easily consumable format with end-to-end working recipes. Recently, Uber has adopted Microsoft Cognitive Services for driver identity verification and aspires to make rides safer. Cognitive Toolkit is widely used behind the scenes to power these use cases. Some of the features such as how-old.net and CaptionBot are powered by Microsoft Cognitive Services. How-old.net is an app that predicts the age of the individuals in a picture. On the right-hand side, you can see that Microsoft CaptionBot is able to automatically derive linguistically rich, accurate textual descriptions of the image. Both these applications are made possible by features available via CNTK or the Cognitive Toolkit. Here is another application where Liebherr, a refrigerator company, is using deep learning technologies from CNTK to power next generation smart refrigerators. Using CNTK's state-of-the-art vision solution, one is able to identify regions with different objects in the refrigerator. Microsoft researchers went into the history books by reaching human parity in conversational speech recognition, achieving a word error rate of only 5.9%, enabled by CNTK's multi-server scalability. The reference provided has the details of this breakthrough work. This was primarily made possible because the model training task was made faster by Cognitive Toolkit. On other toolkits, this task would have taken months at a time. With Cognitive Toolkit, the team was able to cut down the training time to a week, allowing for rapid iterations and model tuning. In claiming CNTK is production ready with state-of-the-art accuracy, efficiency, and scalability with multi-server and multi-GPU support, here are some of the results from a benchmarking effort by researchers from Hong Kong University. In this effort, those researchers have benchmarked several deep learning toolkits against popular neural network models. You can see that fully connected networks and LSTM implementations in Cognitive Toolkit compared favorably against other well-established toolkits. For ResNet, CNTK performance is very close to Torch. More details can be found in the paper below. At Supercomputing Conference 2016 in Salt Lake City, NVIDIA announced deep partnership with Microsoft to deliver artificial intelligence applications to businesses by leveraging speed and scalability powered by Cognitive Toolkit. You can read the article cited here for more details around what Cognitive Toolkit provides to our customers in Azure as well as NVIDIA customers. In the spirit of open source, Microsoft Cognitive Toolkit incorporates several easy-to-follow tutorials available from our GitHub site. We are constantly listening to you while adding tutorials. We appreciate your feedback. You can browse the source code by clicking on these links. You can go to the tutorials. If you have issues, you can post issues there. You can create a fork if you want to take some pieces of the code from the toolkit and build your own applications, or express your likes by giving us a star. To run the tutorials, you can run them locally on your own box by following the installation instructions posted and using the automated installers that is recommended for either Windows or Linux machines. Or you may choose to run these tutorials on our Azure Notebook site. What you need to do is you can go to notebook.azure.com/library/CNTK beta 2. Then you can hit clone and run the notebooks. The notebooks run under your own virtual environment, thus requiring you to sign in using either outlook.com, hotmail.com, or live.com, any one of the Microsoft email IDs that you can create for free. You may choose one of the notebooks and step through the tutorials by clicking on the Run Cell button here, or using keyboard shortcuts such as Shift plus Enter simultaneously. Note these cells are blocks of active code. You can play around with the parameters for the tutorial that is made available to you via these notebooks, and explore ways to get trained on how the toolkit works. The code provided to you scales on both CPUs and GPUs equally. The Azure instances you run are open to anyone and everyone at no cost. However, these are running on CPUs machines and do not scale well for very large data sets for which you need to run these on your own machines. And if the data sets are very large, you can run them on a CPU machine, but the real power of CNTK comes through scalability, and if you want the training time to be shorter, then we recommend that you use a GPU enabled machine powered by NVIDIA. The toolkit can be found at our GitHub site here, github.com/Microsoft/CNTK. There's a wiki site. You can post any issues you may run into. Either you can do it here in GitHub or you can post it on Stack Overflow. In conclusion, Cognitive Toolkit provides easy to use library of very performant deep learning applications supporting very large production scale data. With its recent release of the Python APIs, Cognitive Toolkit offers a very flexible framework. We build and test for both Linux and Windows platforms. We embrace a completely open development environment in the spirit of democratizing AI. Besides GitHub and Stack Overflow, you can reach us on the CNTK help at Microsoft.com. We welcome you to try out the Cognitive Toolkit. Please get started with our tutorials either locally on your machine after installing CNTK or on Azure using the link provided above. Thank you.